Welcome back to Principles of Electronics, lesson number 8, potentiometers. I'm going to give you a quick intro to a potentiometer and what we can do with it. Basically, a potentiometer is a variable resistor. We've gone over resistors, we've talked about them already. Now, when we talked about them before, we talked about the values being fixed, 10K, 100K, 2K, 5K, whatever. Now we have a component that we can vary the resistor. It makes it very useful for making things change on the dime, not have to switch out fixed values. So the way that works is potentiometers, as you can see in this diagram, have a knob, and when you turn the knob, the resistance changes. Now there's 3 pins, don't worry about this here, but there's 3 pins, 1, 2, and 3, and you can see in the schematic, or the symbol, there are 3 pins labeled 1, 2, and 3, to where this is number 1, the middle is number 2, and the other side is number 3. Now, number 2 is called the wiper. The wiper, let me go back to blue. The wiper is the middle pin, and it's attached to this arm here that then, when the knob is moved, rotates it across the resistive track. So, for example, we can hook this up several different ways. But if we put a meter between 1 and 2, and then 2 and 3, and then 1 and 3, this is what we would get. First of all, if this potentiometer was rated, let's just say at 10K, 10 kilo ohm. I'm going to make that a little bit bigger, 10 kilo ohm. Then the resistance, if we measured it between 1 and 3, would be equal to 10K. And the resistance, if we measured it between 1 and 2, and then added that to the resistance that we measured between 2 and 3, is equal to the resistance between 1 and 3, the overall resistance of 10K. Now, what these values are, the resistances, depends on where this wiper is. So, for example, let's say we have this wiper set straight up at 50%. If it's set at 50%, then this resistance 1, 2 is going to be 5K. The resistance 2, 3 is going to be 5K because we're taking 50% of the overall. And then that's going to, of course, equal 10K, which is what we said needed to happen. Now, if we take this over to 25%, then the resistance between 1 and 2 is only going to be 25% of the total. So that's going to be 2.5K, or 2,500. And then the rest of it is 75% of the 10K, which is 7.5K. And that's still going to equal 10 kilo ohm. So it's important to know that wherever we have that wiper, that when we add up our 1, 2 plus our 2, 3, we're always going to come up with that total. Now let's look at a very, very easy application. And I just hocked a schematic from somebody instead of drawing it out and make it easier. We have a battery, and let's just say, I don't know, we'll make that 10 volts. And let's make the potentiometer, we'll just make it 10K. It doesn't matter. And this resistor up here, let's make that 100 ohm. A lot of ones and zeros. We're going to discuss why this resistor is needed in just a minute. And then we have an LED. So as we change this resistance, we talked about this before, but as the resistance increases, the current has to go down. Likewise, if the resistance goes down, the current has to increase. And of course, this is based on Ohm's law. This is constant. If this goes down, that has to go up. If that goes down, that has to go up. So, as we adjust this potentiometer, and notice here we're only using 2 pins. So let's just say that's 1, that's 2, and that's 3. 3 we're not using. We don't need to use it because we're just going to use the resistance between 1 and 2, which over here is between these two, and we can change that resistance by changing the wiper to pin 2. All right, so let's say, for example, that you know, we open this up a little bit, and our resistance, let's say we're at the 75 point over here, 75%. So if we're at 75% between 1 and 2, then our resistance is going to be 7,500 ohms, 7.5 ohms, and which means we're going to be limiting pretty heavily the current going to this LED. Now, if then we turn it back to 25%, our resistance is going to go down. If our resistance goes down, our current goes up, and that LED gets brighter. What we've just created here is a dimmer for our LED. Very simple circuit, very easy to do, a good one to get used to what a potentiometer does. Now, why do we have to have this other resistor up here? Well, in the case that we forget and we take this wiper and accidentally turn it all the way down to where our resistance now is 0 ohm. So now we've turned it so there's no resistance whatsoever. If we don't have this potentiometer in here, and I'm sorry, this resistor, and there's no resistance in the potentiometer, then we have no limiting resistor or resistance in our circuit at all, which means we could damage or burn out this LED. Instead, we put this 100 ohm in there just in case this goes down to 0. We still have protected our LED. Now, it may not protect it very long, it's only 100 ohm, but at least we have it there until we turn the knob back and get some resistance in our potentiometer. So there you have it, potentiometer, very easy to use, very versatile, gives us a lot of different options. If you have any questions, leave them in the comments, and as always, please subscribe to Sprider Web Education.